our next example comes from a released AP free response question. Let's take a look. It's kind of strange. Just a warning. Oh yeah, and also if you have arc length for part of your free response question, just realize that it's going to be embedded as just one small little piece of something larger. Maybe you have to do area, volume, something like that. Let's take a look. A baker is creating a birthday cake. The base of the cake is the region R in the first quadrant under the graph of y equals f of x between 0 and 30, where f of x is equal to 20 times the sine of pi x over 30. Obviously, I mean, yeah, this baker, am I right? Okay, both x and y are measured in centimeters. The region R is shown in the figure, and the derivative of f is given to us as well. Like we couldn't do that by hand? Huh. Okay, whatever. The region R is cut out of a 30 by 30 centimeter by 20 centimeter rectangular sheet of cardboard, and the remaining cardboard is discarded. Find the area of the discarded cardboard. So weird. All right, so here's what's going on here. I've got a 20 by 30 piece of cardboard. Yeah, that didn't exactly move exactly where. Okay, so maybe, yep, there we go. Kind of close enough. All right, and then by 30. Yep, that looks good. And so basically what is happening here, if this is giving you fits here, I will go ahead and erase the other part that we didn't want. Okay, there we go. Does that make you feel better? Right? Okay, good. Yeah, we're going to get rid of this part that I'm going to shade. So really, that's the area that we want. We kind of want the negative part of it. By negative, I mean like in terms of like what's left over, not the negation of. Anyway, so the technique then is going to be like this. We're going to take rectangle, and then we're going to subtract out area underneath the curve, right? Oh, I just made like a face. Look, these are two eyes, and this is a big old mouth. Okay, so to find the area of the rectangle, obviously, we're just going to do a 20 times 30. It is in centimeters after all. This is a calculator active question, so you don't even have to work that out if you don't want to. And then we're going to subtract out the area underneath the curve here, this definite integral, from 0 to 30 of, and that's just the area underneath the curve here, which is 20. I'm not even going to write that. Come on, just write f of x dx, because we're going to punch this into the calculator. And so I've done that part before I even started this video. I put this in y1 and I put this one in y2 just in case I need it. I will need it later. But anyway, so let's just punch that into the calculator here and then find the area of the discarded cardboard. Oh, do you want to see this picture? It's cute. So there's Rowan when he was an outstanding student of, I don't know what grade this was. No idea. But look at this kid over here. He's not very happy about it. Anyway. Yeah, Rowan. Okay, what was I doing? Oh, yeah, before I got distracted. All right, so again, I put both of those functions, y1 and y2, in case we needed them. Quit back to the home screen, and I'm going to do, it was 20 times 30 first, right? So there's the area of the rectangular piece, minus, and now we want the area underneath the curve, so math number 9, from 0 to 30. Yep. And then inside here, we just have our function, and our function was just like y1, right? Okay, no need to square it, no need to put any pi. We're not doing volume, not yet anyway. And then throw an x on it right here. Okay. And then make sure that you round this thing to 3 decimal places. So 218, this is in square centimeters, 218.028 square centimeters. Did it ask for units? No, it didn't. And if you don't put them, don't worry about it, because if they want them, they ask for them. Okay, let's go back over here. Let's see what the next part of this is going to ask of us. Scroll down here. And so same setup. Okay, so now we're down below here. The cake is a solid with base R. And this is going to be the base of our cake. Cross sections of the cake perpendicular to the x-axis are semicircles. All right, and then questions continued over here. If the baker uses 0.05 gram of unsweetened chocolate for each cubic centimeter of cake, how many grams of unsweetened chocolate will be in the cake? Okay, just weird. So in order to answer the question about the chocolate, we need volume, right? How do I know I need volume? Each cubic centimeter of cake. Cubic centimeter, of course, is volume. So it's like our scale factor is this. 1 cubic centimeter is equal to 0.05 grams of unsweetened chocolate, conversion factor. So in dimensional analysis, let's say that we have some sort of question mark for our cubic centimeter that we're going to figure out on the calculator just a little bit. And then I need to figure out, like turn this into grams of chocolate. So I need my cubic centimeters to disappear, and then my 0.05 grams up top. And then obviously I can see that all I'm going to have to do is just multiply by my final answer by 0.05, right? Okay, yeah, that was probably obvious. So speaking of obvious and maybe not so obvious, let's throw in our representative rectangle, something like this. Okay, this guy here, right, it did say is perpendicular to the x-axis. These things are going to be semicircular cross sections. So let's sketch something here so we can wrap our head around it. And then I'll draw another one kind of offset from this one to make this sort of look like a taco. Whoa, I don't know what happened to that. Okay, there we go. Does that look right? Oh, it looks great. Okay, anyway, so this rectangle here is the same rectangle as this one, and we have a delta x for our width of that thing. Delta x. XX? No. Delta x. There we go. And now remember that in order to find the volume of this, it is basically half of a cylinder, and that would be 1/2 pi r squared kind of thing. So I need an r. I need the radius. So the radius, if I draw that on here, is basically that length. And that is right there, this length, right? Okay, so that's just basically half of our function, 1/2 of f of x. And I think that we're ready to go. So remember that the area of our base, we're just going to integrate the area formula, is 1/2 of pi r squared. This 1/2 and that 1/2 are totally different, so make sure you put both of them in there. Okay, so our volume are actually, you know what I'm going to do? I'm just going to put this scalar right out front, this 0.05 times the definite integral from 0 to 30 still, and I need a 1/2 pi times my radius, and my radius is 1/2 of f of x quantity squared. And then throw a dx there. Right, so have that on your paper and you're good to go. And you can throw all of this into your calculator because we have this thing stored in our calculator as y1. You could, if you wanted to, bring all of this stuff out. You'd square that thing, take this, multiply it together, bring it on the outside. But since you're plugging this into the calculator, there's really no point. And why even take a risk? All right, so have that memorized so that you can call it out to me as I plug it into the calculator, please. Thank you. Okay, or either that or I'm going to just try to stumble my way through it. Okay, so first I had 0.05 right there. Okay, yeah. Okay, then our definite integral, math 9, and then from 0 to 3,000, I think it was, right? Wasn't it like 3? No, it wasn't. Are you kidding me? It was just 30. Get rid of all this. Come on. Yeah, want that one in there. And then here we have our 1/2 pi. Pi. There we go. H. Brilliant. 1/2 pi. Okay, yeah, there we go. And then we want to square our function. 1/2 of our function. I'm going to go ahead and put that in parentheses. So 0.5 of y1 and then I'll close the parentheses and then square it here, and then throw an X at the end of this whole thing, and then hope for the best. Da-da-da-da. And here we go, rounding that, or just truncating it. We have 117.809 or 810 grams of unsweetened chocolate. Sounds delicious. Okay. All right, I think that there is one more part to this, just one more part, and it still uses the same exact cake setup with those cross sections being semicircles, but here is the last part. Find the perimeter of the base of the cake. Ta-da! Finally, the application specific to this lesson. Finding the perimeter of the cake. I need the straight part here, and then plus the curvy bit. Okay, so the straight part is just a 30. Don't forget that part. And then for the curved part, we'll have to use our arc length formula. And remember that our arc length formula needs the derivative of our function, which is the reason why they gave this to us. And they probably gave it to us just because, hey, this is a calculator active question, and some people could have been confused or something and tried to just do the derivative inside the calculator, and it would totally fail on them. So then let's go ahead and set this up on paper, throw it into the calculator, and then have a sandwich or maybe a piece of cake. I don't know. So our perimeter, I'll just call that P, is equal to, I want to put my 30 for my straight segment piece, plus the definite integral from 0 to 30 of, and now use the Pythagorean theorem here, 1 plus our derivative. It's called f prime, so I can call it f prime too, squared, and then dx. In my calculator, I put this in as y2. Hopefully you did as well. Look, that's it. We just plug that into the calculator and it's done. One more time in the calculator, if you please. So start with your 30. Let's zoom in. Yeah, that looks good. Looks real good. Nice clarity. 30 plus or minus. I mean, whatever. Hey, why don't I do minus a minus just for fun? No, I'm just kidding. Plus, we want our definite integral. So one more time, from 0 to 30. And then we want to throw in our square root, 1 plus, and then we have our y2 that we're going to square this time. So alpha f4, and then number 2, and then just square it right there. You don't need to put parentheses on that one. Only put parentheses on this one because I was multiplying it by 0.5. Red. Okay, anyway. And then an x. Ta-da, you can probably bet that 30 was commonly left off. And who knows, this might have been 2 questions. I mean, I could look it up, but I'm too lazy to do it. It was probably worth 2 questions where this was worth a point, and then this final answer was worth a point, which you couldn't get unless you had that 30, of course. And then we want to round it 3 decimal places, so you can either do this or change that 3 to a 4 because you got that 7 there. And there you go. Calculus of cakes.